Hey everybody, welcome to the Kansas City Java user group for May of 2020. Tonight we're going to be talking with Sendil, who is a engineering manager at Uber and also a core member of the JHipster team, and he's going to be talking to us about building reactive microservices with JHipster and Kubernetes. My name is Brandon Heck, and on behalf of the users and community, I welcome everybody to our stream. We want to thank our sponsors. Right now, we have Clinical Reference Laboratory, which is sponsoring our meetup.com fees. So thank you to them. And we also have Oracle, which unfortunately we didn't get added to the slide, who is sponsoring our StreamYard membership, which is how we're presenting the stream to you tonight. So in Java news this month, we've got JDK 19 features starting to ramp up. Some that we wanted to point out were virtual threads, record patterns, and structured concurrency. Everybody probably knows virtual threads is Project Loom. Record patterns is kind of some just interesting stuff, syntactic sugar, and structured concurrency is related to Project Loom, but it's kind of going to be delivered independently. So virtual threads are lightweight threads. They exist in memory, and the JVM can park those so that they don't have to always be using an actual thread from the operating system. And this is going to allow for much higher concurrency. Record patterns, I mentioned, are a little bit of syntactic sugar. So this is especially going to be useful in instance of, so you can basically do the instance of and object cast in the same block of code. You can also specify different things within the record and reference those pieces directly, such as in the second example here, where we're printing out the color of the colored point in the rectangle. And structured concurrency is going to be a new library which is designed to help better handle multi-threaded applications. I mentioned it's part of Loom related, but is going to be delivered separately. It's not going to be a replacement for the Java concurrency that we know and love, but it's going to be something new that is potentially better for that. Releases over the last month, we don't have a ton. Jakarta EE 9.1 was released. There are a few features that were added in there that look pretty cool. So if you're developing on Jakarta EE, you might check that out. And Test Containers 1.17 was released. One of the big callouts that I'll shout out there is that if you are limited in your CI environment from using the Reactor container to manage all the other containers that Test Containers spins up, they've now pulled that out and it can be run inside of the JVM. Doesn't do quite as good of a job, but it does allow a little bit of cleanup at least. In other news, we've got a few conferences coming up that we're going to call out. UberConf is coming up in July. It's the 12th through 15th. This is in Denver. It's going to be virtual or in person, and registration is open at uberconf.com. KCDC coming up in August. We are encouraging members of the Kansas City Java user group to attend KCDC in lieu of the Kansas City Java user group for August. We will not be having a meetup because of that, but it is in person at the Kansas City Convention Center. I think there's also a virtual option. Registration is open right now, kcdc.info, and Java 1 is making its return. I'm sure we've all heard about this again. It's going to go concurrent with Oracle's Open World. I think that's what it's called. And it's going to be in person at Caesars Forum in Las Vegas, Nevada. And KCDC is also looking for volunteers. So if you are a member of the Kansas City developers community and you want to get involved with some of the cool stuff that we do here in Kansas City, Gabby Sperling would love to have you reach out, gabby@kcdc.info, to get more information or to volunteer. We don't have any local upcoming meetups that we want to call out right now. We will have a Kansas City Java user group in June. Right now, we do not have that scheduled. If there's anything we miss, call it out in the comments. We'll be happy to shout it out. And as always, get involved with the Kansas City Java User Group. Our success is dependent on the community. So tell your friends, like and subscribe to the YouTube channel, suggest topics, speakers. When we start doing in-person meetings again, we'll want locations. You can volunteer to speak. Our paper call should be working now. If it's not, please let us know. You can follow us on Twitter at KCJug or provide feedback, and we'll make that link available. All right, so with that, I'm going to bring
folks.
Sendil back on the screen. All right, Sendil, I'll turn it over to you.
Yeah, thanks, Brandon. Thanks for the introduction and also the awesome news. Hey, folks, welcome to the beta, and let's talk about Reactive Microservices with JHipster and also run it on top of Kubernetes. That's what we're going to do, and let's get started. I'm Sendil. I'm an engineering manager at Uber, and also you can reach out to me at this handle if you have any questions about this presentation, or in general you want to chat about JHipster and Kotlin Hipster. Cool. Let's start with why microservices. We all know microservices is everywhere, and the adoption of microservices significantly increased over the last few years, and every company out there is trying to use microservices in one or other way. And the reason it offers a lot of benefits, and it's also becoming a de facto standard for the development, but it also comes with a lot of pain, right? So it is not only benefits, but it also has a lot of dark side too. And these individual services makes our life better and also worse. But at the point, there is a lot of benefits that is added to the microservices, and let's see a few of the benefits that it gives us. The first and foremost thing is the ability to scale as per our needs. The rigid monolithic architecture always pushes to scale everything or nothing. But in the case of microservices, the flexibility to scale only those services that is required for and that are essential for our customer satisfaction is very there. And also it reduces a bunch of cost and increases the customer experience. That's also one of the bigger things with the scaling as per our need. But it's very important that these services should be isolated or kind of live in their own environment. If they are interdependent, the interdependent microservices are not microservices, and they are nothing but the gateway to the problems that you're going to have, and maintaining that is a nightmare. Of all the features or all the advantages microservices bring in, one of the things that clearly stands out is the fault isolation stuff, where if something is not working, you can just remove that service out of the picture and your entire application should work fine. It might be missing some functionalities, but end to end, you might be able to attend to customers, you might be able to deliver functionalities for the customers. And that is one of the killer features of the microservices. But these services own some business functionality. For example, you can call them as like some APIs. You can group few APIs together and build it. And all the other services or consumers that are going to access them, it can access them via a network protocol. And like things like HTTP or any fancy framework that comes in day out, you can use them. But these are completely isolated entity, and they should own their own data. And the microservices should avoid using something like shared databases in most of the circumstances. And each microservice or each service inside your microservice architecture should encapsulate its own data. And one of the important things when you think about microservices is how independent they are, whether you can deploy them independently. It is very important, but it requires a lot of discipline and a clear-cut release approach to make sure your services are independently deployable. If you don't have this feature, it's going to be a big nightmare for you to deliver incremental features and also ride on top of the advantages that microservices provides you. So it is very important that your microservices should have independent deployability inside it. So also like you can think about microservices as like black boxes. So it defines, you can have a contract for every service that it's going to have. So for a given request, it will give you a particular set of response. You need not worry about the implementation of how it's going to happen, but the interconnections, when it happens, the contract remains valid, and each of these services would actually validate the contract. The services might be written in any of the languages. It can be in JavaScript, it can be in Haskell, it can be in Visual Basic or Java, anywhere. You can have any language inside. You need not worry about it. But the contract should be accepted and contract should be maintained between these microservices. And that is very important in case of microservices. And that pushes us to isolate the components, but also make sure that we are developing correctly. And these services should own the data. Every service that you're seeing should have its own data, and it should encapsulate the data. It should be the owner of the data. You should not have shared mutable state between these services. Having a shared mutable state between these services will create a single point of failure. And whenever you have a single point of failure in a microservice architecture, you should try and avoid them. Otherwise, you will have a lot of pain in maintaining that services. So with isolation and independent deployability, and also removing the single point of failure, it provides you a robust microservice architecture. And a good microservices are really happy place to work on. It increases the productivity of the team. It decreases the cost a little bit when you scale in much higher. And it also reduces the organizational complexities that we are going to see with microservices. And in case of microservices, just think about this thing whenever you're building a service. It should do one thing and it should do that well. It should just focus on doing that. It should have this independent deployability built in. This requires a lot of discipline and also like a lot of organizational thinking when you're building that stuff. And it should not have a single point of failure inside anywhere. Anywhere you're going to see a single point of failure, try to remove that single point of failure. The best example or the most common thing that happens is shared database. Do not have shared database between your services. That brings up a good microservice architecture, right? But why do we need something more than that? Microservices addresses few of the issues. Why do we need something more than that? Why do you need something like reactive microservices here? So the benefits of microservices, adding to its shortcomings too, we can provide some set of architecture where you can experiment faster, roll out things faster, and move faster. But when you take into microservices, it kind of expands and scales in a much larger scale. When it scales beyond some limit, it's very difficult for us to wire them together and get the values at a particular time. Like you cannot maintain the latency and the availability of these services. And it takes, if you have hundreds of different services, if your service request hops between these services, then the latency of your application is going to increase. And that's the main reason why we need something like reactive microservices to take the benefit of the modern architecture and use asynchronous a lot such that it can save the latency and also makes your application super fast. And building application, the expectation and the user base, it's getting bigger and bigger. We are going to scale a lot of things. And microservices just addresses the organizational problem that we have, like divide and conquer, like dividing a bigger problem into smaller chunks of problem and creating a services around it and then putting it over there. But it creates a lot of havoc or a lot of problems in terms of like accessing them and also like giving a proper latency or proper SLAs for each of the requests that you're going to give. Previously, what was a function call? Now it became a network call. A network is not reliable. So we are going into the unreliable channel. And how are we going to deliver highly interactive and ultra-fast experiences for our customers with an unreliable channel? And that's a bigger challenge. There is also something like we kind of scale things dynamically here. Believe me or not, like you can start with one or two microservices and believe like that's going to end of the world. But as you scale more, the number of microservices is going to increase exponentially. And when it increases, it's very difficult to maintain it. It's very difficult to try to make sure like the hops that is happening between these microservices are limited and the response comes back faster. So you need a way of like asynchronously calling them and getting benefit out of it. And on the other hand, the modern architecture is not designed for most of the synchronous work. We kind of like reached out the maximum limit for the synchronous work. So we need to have this concurrency and non-blocking, which is the core of the modern architecture. How to use those multiple cores, how to extract all the benefits that a compute is providing, and then use that benefits to deliver application faster. So with all those things together, that provides a necessity for us to go for a reactive microservices. And the function calls that we had in the previous world of monolith has been replaced by the network calls. These network calls can be anything. It can be a protocol of communication. It can be REST over a HTTP network. It can be anything. And these are unreliable, and it adds a lot of latency to your application. So for example, if a client says, hey, get me some data, and you have like 4 different services here, and for each service, for fetching the data, if you're going in a synchronous way where you go and call the first one, you go and call the second one, you go and call the third and fourth one, the latency is like sum of everything that's going to happen, which is way higher. And in this case, it's 170 millisecond, which looks like much smaller. But in a real world, when this number of microservices increases exponentially, the hops will take a longer time to complete, and the time for you to get the data and give it to your customer is going to increase exponentially. In case of using something like asynchronous way of doing it, where you can fire these requests first to the first service, next to the next service, and then to the other service, where you're potentially not waiting for any of the response, but you're just firing those things as a non-blocking events. When you fire those things as non-blocking events, the latency is going to be 100 milliseconds here, which basically means like the latency is the maximum value or the slowest application that you have in the picture. So in this case, my slowest application or the maximum latency that I have is 100 milliseconds, and that will be my latency whenever a user tries to access it. Now, if I have to fix it, I can just go to that 100 millisecond application and try to fix it to reduce the latency even further. And it can go till 50 millisecond, and then I can reduce 50 millisecond latency. So I could have this individual component where I can trigger, turn knobs, and make my application faster. And that is the cool benefit of having a non-blocking call. So if you consider this hexagons as threads, the non-blocking I/O or non-blocking communication is nothing but the thread will not wait for the things to complete. It initiates the work and asks the work to complete. Once the work is complete, the executor that runs inside takes that response and put it back into the request creator. The way I think about it is basically like, for example, you have a database and you have a big select query, and you know that select query is going to take a longer time to execute. What you can just do is like, you can ask your database, hey, get me a value of this, and then you go back and do your work. Inside your application, you go and search for cache, you go and do whatever the thing that is required. And then the work is completed. Once the work is completed, it's thrown back into the executor, and the executor's job is to like fetch that work and give it back to the requester. And it takes care of that. So there is no blocking that is happening over here. And your application can go and do whatever the thing that it wants to do, but the asynchronous work will be completed and given to you back, and then you can run your operations on top of it once you receive it. And this is basically based on this entire reactive paradigm is based on the reactive manifesto, and which highlights the 4 important aspects of your application. Your application being responsive, which basically means like it provides a consistent and rapid response time for your customers. Your application being resilient. The resilience here makes like even when a failure occurs, how resilient your application is. In a microservice architecture, failures always happen. How you're making sure whenever failure happens, how you're trying to go to retry, how many times you're going to retry. And even like if all the retries got expired, what are the next things that you're going to do? How are you going to return an error? How are you going to exit that loop gracefully? Those are the things that you have to think about in a reactive architecture. And the other 2 things are like, if your application scales bigger, how they are going to operate. And that is defined by the elasticity of your application, how good your application is, how elastic your application is. And being asynchronous and loosely coupled services in the world of microservices, everything you can work with a message. So you can send out a message and say like, hey, I sent out this message, and you can fire and forget about it. And then the work will happen, and then eventually you'll get a response, and then you can use that response back to yourself. So asynchronous message passing makes a very important part of your reactive application. So we mean like, in case of asynchronous message passing, it's nothing but you process a request that occurs at an arbitrary point of time, sometime after it has been transmitted from a client to a service. So for example, you send a message from a client to a service, you just fire and forget about it. The request, it goes and does its work and then comes back to the client. In the meanwhile, the client cannot observe or be in a synchronous motion, like be synchronously expect an output from it. It just sends and it removes from its perspective. Once it receives the execution, a callback is called back, then it takes the operation and does the extra operation on top of the data that is called back. So that is the important or core part of your reactive architecture. And in a reactive system, every part of the system, irrespective of where you see, right from the web server in which your application is going to get deployed, the database that you're going to interact with, and all the other things that kind of runs inside the application and the outside surrounding the application, all those things should be reactive in a reactive system. And it is very, very essential for a system completely to be reactive. Having a non-reactive part inside any of your service or an application itself will make it synchronous. Whenever something becomes synchronous, it's going to take more time and you're going to lose all the benefits that you're going to have. So it's very important that every part of the system should be reactive in order to reap the full benefits. And it's very important to see, like, reactive system is not for everybody. It adds in a lot of complexity, just like microservices. Microservices is also not for everybody. And similarly, reactive systems is not for everybody. And if your requests are more than like 750 requests per second, if you have a huge set of users here, doing it for like more than 10 million or more than millions of customers, then you can think about being reactive and building those steps and include these complexities, because then the return of investment of going through these complexities actually increase. So that is the better thing for you. So always think about it. Reactive might look very shiny, but it's not for everybody. And you have to be very sure, like, when you're going to include it and why you need it and how you're going to include it. That's very important. Whenever we talk about reactive, the first library that comes in our mind is RxJava, because it's a JVM implementation on top of reactive implementations. So RxJava is cool, but it also has its confusing elements inside it. But the core concept here is like the RxJava is basically built on top of asynchronous and event-based programs. And that's how we do it. But so you can ask me, hey, Sendil, what's the connection between the RxJava and what we are going to do today? So basically, we're going to talk about Spring. So we all do microservices with Spring. Spring makes it much more easier for us to build microservices. And Spring 5 added a small dependency or added a small implementation called as WebFlux implementation. And that supports the reactive programming altogether. And Spring 2.0, Spring Boot 2.0 came up with reactive programming support built on top of the same WebFlux using Spring 5. And Spring Boot simplified a lot of things for us. And it almost like everywhere you go and see Spring Boot is something that we are using everywhere. So it is everywhere. And it also makes it much more easier. Just add a couple of annotations, just include the proper dependencies. You got everything there and your application kickstarts and runs. So Spring Boot made it very easier for us. And there we have this reactive Spring, which was built on top of Project Reactor. And the APIs that Project Reactor exposes, or the way in which you write your reactive code, the API in which you have for the reactive code, were loosely based on RxJava. RxJava is basically the inspiration for building those things on top of it. And Spring actually made it much more simpler. As with every way, Spring makes it much more simpler for us to write the applications. And also, it made it much more simpler for building and writing reactive application. So for example, when you use a Spring MVC, this is how the code will look like. Yeah, for example, this is an API method inside your user resource or a controller, however you want to call it. So there is this user's endpoint, which goes in post, which is a post request, and which is a post method, and calls the create user endpoint, create user method. And here, I'm just returning a user once I create it. So first step, I'm going to save it in a database. This is asynchronous. I'm going to wait. The save has to happen. Once the save is finished, I go and return it. And I create a response entity around it, put everything around it, put all the values inside it. And then I return the value to the end user who tried to create a user. In case of reactive world, when you're going to write the reactive part of it, the major difference is like the entire syntax of the application or entire context of the application remains the same because Spring makes it much more simpler for us. The idea of adding like WebFlux, you're going to return, instead of a user, you're going to return something called as mono of user. And even in your application, if you see, you're not waiting for everything to complete. You're not writing a synchronous code there. You're writing a continual sequence of things that will happen as a pipeline. So once you save it, the flat map will do, and where you do a lot of operations in the data, this can happen in parallel. And finally, you map and return the value. The important thing to note here is like, if I don't subscribe, or else, just for this example, if I don't have this map at the end and the flat map at the end, if I just do the save, it is not 100% that I'm subscribing to the data, so I might not get a result back, because whenever you have the streams open, you have to subscribe to the stream in order to receive the data out of it. And that is very essential. Spring kind of wraps this around for us. Spring Boot makes it much more easier, and Spring WebFlux makes it much more easier for wrapping things around for us. And it's very important to know, whenever you create a stream, you have to subscribe to the stream to get the value out of it. And then I think we call it mono here. Mono means you can have 1 or 0 users in this case. If you're going to have a list of users, in the reactive world, we'll use flux of users. That's the major difference if you're going to have here. So in the world of Spring, this is how our application is architected, right? So you have a gateway if you're doing a microservice. So if you have a gateway and a list of different microservices, in our case, it's service A and service B. And then you can have a database that it connects to, and then it can be a Kafka or a message queue that it connects to. This is kind of a Spring-based microservices architecture. You can say which uses gateway pattern or BFF pattern. And in the world of Spring, what they're doing, in the world of Reactive, what they're doing is like Spring made all these connections more reactive, which means that they introduced R2DBC on top of SQL, which made connecting with SQL reactive. Reactive and SQL are oxymorons for sure, but we have this library which kind of makes it much more simpler and exposes a reactive way of connecting and getting the data out of it. The gateway and these services, they interact together via reactive mechanism. And the messaging, we have a separate library which helps us to put reactive data inside Kafka and get the subscribe and get it from the channel to via Kafka. All those things are two-way communication here. Similarly, Spring also makes sure like we don't need to have an extra, or we cannot run this entire reactive thing inside the existing Tomcat or Netty server that we had. So Spring made it easier for us to run all those things on a reactive-based server. So they also created those libraries for us, which makes it much more easier for us to run a reactive application inside those server. So this is the overall architecture of Spring Boot 2.0, where you have this reactor as a core dependency for reactive stack and an optional dependency for the serverless stack, which is a normal Spring application that we used to do before Spring 2.0. And as you can see here, there is a servlet containers. All of them are made reactive. They are separate for reactive and separate for the normal ones. And then you have the adapters that kind of helps us to connect these two things together. And then finally, we also have Spring Security Reactive, Spring Data Reactive, and then Spring WebFlux instead of Spring MAC. So we have this one-on-one mapping between the normal one and the reactive one. So Spring made it much more easier for us to use those things. They can expose similar APIs, and that also made it easier for us to learn and also to deliver applications together with Spring. So being reactive makes our applications more responsive, resilient, elastic, and also it's a message-driven architecture is there. And Spring 2.0 makes it much more easier for us to do reactive programming, basically built on top of like the easy way of understanding and writing the Spring-based microservices with the reactive stuff. But it's a lot of changes that we have, which requires a lot of minor details, changes, and things like that, including a lot of new libraries and things like that. And if you're like that, if you're lazy like me, then JHipster is a perfect one that could help you out here. So what is a JHipster? I'd like to call JHipster as it's an application generator or a full stack application generator. It's an open source project, of course, and it creates a Spring-based backend which is written either in Java or Kotlin. You can choose between them. And a front end, which is you can pick your favorite framework. We do support most of the highly used frameworks in the front end side. So you can pick your favorite framework over there and then put it over there. So it creates a full stack application together for you. And I would also call this as a development platform, because this kind of not only stops itself from just generating the application and throwing it out in the wild and then moving away from it. It creates all the dependencies that is required for you. For example, when you're writing full stack application today, you might need a Docker component for that. You might need to run it on a create containers out of it, run as an image, run as a Docker containers. We create all those files for you, so you can very well, from the first day, the production ready code that has been created by JHipster is ready to run on cloud native way inside a Docker. You can create Kubernetes containers. We will see today how to create Kubernetes files, configuration files, so that you can deploy Kubernetes without much fuss. And also it creates CI/CD pipelines and most of the other things that you would require in a modern day-to-day application. And it creates an entire package of all the good things, and you can just use them together. And that's why I would like to call JHipster as a development platform here. And it creates all the bells and whistles that you require. It creates a production-ready application from the first go. You can just create it, launch it to production. It has like entity generators and things like that. We will take a look at how we can do that today and how easy JHipster makes it to create all those applications for you. And if you think about JHipster, I would see like in JHipster it has like multiple different components or modules inside. And these modules are responsible for generating that particular part of it. So we have something called server module, and the server module is responsible for generating the server code, like the code that runs on the server side. It is your Spring-based application. It can be either in Java or Kotlin. And then you have this client-side module. And the client-side module's major functionality is to generate an application on the client side, which is Angular, React, Vue, or Svelte-based front-end, and it just creates its front-end. The contract that was defined on the server side is actually maintained on the client side too. And then you have something called deployment module, and the deployment module's main job is to create the deployment files for you. So the Docker, Kubernetes configuration, or AWS configuration to put it on GAE, GCP, and things like that. It creates all those things, deployment configuration for you. And then it also creates CI/CD templates. So in this case, it creates like, you can also ask JHipster to create a CI/CD template for your GitHub. If you're hosting your project on GitHub, it creates GitHub Actions files. So you need not worry about it. If you just want Sonar, it is automatically added to your file, and it uses that Sonar module and runs it once you upload your code into your this SEM platform that you're using. So it kind of creates all those things. And the main reason of those modules is like, main advantage of these modules is like, tomorrow if you say, hey, the client that was generated by JHipster, I don't like it, I want to change the client, you can just plug and play it. You can just create your own client and then put it across together. If you're saying, hey, Java and Kotlin, I don't want either of this, I'm still having my code in Scala, I don't know why you would do that, but if you still have your code in Scala, then you could say like, okay, I'm going to write my server side in Scala and plug that out and use the generator version of yours, and then you can combine these things together and run it as a single application generator. And that is the advantage of JHipster and the modules that it provides. So how you can generate or how you can use JHipster? The first thing you have to do, JHipster is a node package or a JavaScript package. So you're going to run npm install -g for global, and generate a JHipster, which is a package name. This is going to install this JHipster package on your CLI. So then you can go ahead and create an application, for example, create an directory, and then go into the directory. Inside the directory, you can just run JHipster command. And it's going to ask you a bunch of questions, and those bunch of questions will determine what kind of application that you're going to generate and what are the things that has to be inside the application. So in our case, there are like a few questions. I'm just going to highlight the few ones that are most important. The first thing is like what kind of application you're going to generate. It can be a monolith application. It can be a microservice. It can be a gateway application, as you've seen in the diagram before. And whether you want to use reactive or not. So if you are going to use Spring WebFlux, which means reactive, and Spring MAC is a normal one. what kind of authentication you want to use. We support OAuth 2 out of the box. We support session-based authentication and all those authentication that you normally use in your application. What are the database that you support? We support most of the highly used database, both SQL and NoSQL databases, so you can choose from the wide variety that we have. And again, the classic question, whether you want to use Maven versus Gradle, what is the thing that you would like to do? And finally, the web framework. What are the web framework options that you want to use? Whether you want to use Angular, React, or Vue, or you want to use some extra testing library in the front-end ecosystem like Cypress and things like that, you can choose those options, and we will build the application as per your request. So it's basically whatever you want. You just put in, select those things from the options that we have, and then create your own application and then deploy it. Once the application is generated, the entire application is kind of like a normal Spring-based application with all the best practices and everything added to it, which basically means like you can change it as and how you want it. There is no problem with that. So that's also one of the bigger things with JHipster. And if you're worried like, oh, that's too many things, I don't want to do a lot of things on it, on the CLI, I just want to like visually see how things are working, then you also have start.jhipster.tech, which basically makes it much more easier for you to generate application and upload those application into GitHub or anywhere straight away. So here, instead of you selecting from the CLI tool, you're just going to click on certain areas, and then you can just generate your application. And you can also make sure the application goes straight into your SEO. So that's enough about everything. Let's go and see the demo part of it. So I'm just going to change my... So today what we're going to do is like we're just going to generate a JHipster application, just the Reactive Microservices application, and we are going to try and deploy this in Kubernetes. As you can see, there are 3 different ways in which you can generate an application. 1, you can just run the JHipster command and go through that instruction. 2, you can go to start.jhipster.tech and try to build that application, like selecting those checkboxes and build that application. And the third option is using a JDL. JDL is called as JHipster Description Language. It's a small stuff where you can just put out your application in the form of a DSL, whatever you require for an application, and we will just generate the application based on that. So I have a file called app.jdl in this folder. And as you can see, like this has an application block. There are 2 applications block that we have inside here. So there are 2 application block and a list of entity. So if you take a look at it, application comes up with a configuration. So if you take a look at the configuration, we first define the name of the application. In our case, it's called as KC Gateway. We also say it's reactive true, which basically means I want a reactive application here. And then you define the package name. I'm putting in the application type as gateway. We are going to generate a microservice application here. And a microservice application, we support BFF pattern, which means we require 1 gateway and a list of microservices there. So that this is going to be the main gateway through which our users enter. We're also saying the build tool is Gradle over here. We're saying specifying the client framework as React. So we're going to use React. The database is PostgreSQL for the production, and this is for the KC Gateway. Remember, the database has to be specific for a microservice. We also make it sure, like here, for every microservice or for every gateway, there's a different database over here. We also say we are going to use Eureka for service discovery, and it kind of uses Spring Cloud Gateway for here. And then we, as I said, you can also choose the framework of test here. I'm adding a Cypress here to do end-to-end testing for me, which makes it much more simpler. And I also added like every application comes up with a list of entities attached to it. And this list of entities basically says like, these are the entity or these are the tables that I want to create for this application. And I here have like 3 entities, block, post, and tag. And you can define an entity. These are pretty similar to JPA stuff, where I've defined an entity and the name of the entity as block, and then the fields inside. So as you can see here, I've defined the name, the type of this name, it's a string here, whether it's required or not required, and any other validations or extra thing that I want to add over here. Similarly, I have defined post, tag, and added to that, JHipster also allows you to decide the relationship between those entities. So here, I'm having many-to-one relationship between post and block. Similarly, many-to-many between post and attack. And I kind of create this together over here. So there is the second application here I have, which is KC block, which is also reactive. I put in a different package name, and I specify this as an application type of microservice. And I'm going to specify the build tool here, a database here. So I can choose a dev database and a prod database. And then I'm going to use Neo4j for that. I also have the client framework as a React here. So we can either have it or we can remove it. So the difference between having it and removing is basically like, if you have it here, then I'm going to generate a micro frontend based application, which means my frontend will live on both the applications. And we use micro frontend architecture to wire them together to build an application and show it to. So it's kind of microservices on the frontend. If we don't have it, then it basically removes it, and it just have all the code related to the front-end architecture inside the gateway. So every entity, everything that lives inside the KC block will actually live inside the front-end part alone will live inside the main gateway application. If you put this client framework here, then it's going to generate you the micro front-end architecture, which we are going to use it now. And again, like a Hibernate cache, if you want to enable it or not. I'm also defining a port. And again, the service discovery type here is going to be array. And I'm defining the entities here, block, post, and tag, which will also be part of this KC block. And finally, I can also determine how I'm going to paginate those entities, whether I'm going to have an infinite scroll, whether I'm just going to paginate it based on the numbers. And I can also specify a microservice, the block and post and tag will be with the microservice named KC block. And this is the name of the microservice that I've defined. Similarly, I can also determine how my deployment should look like. In this case, I'm going to say my deployment type is Docker Compose, so it is going to generate the Docker Compose files for me. And then I'm going to put in the app folders. Again, the app folder should have its own name. Here, I'm going to put KC blog, and the other name that I have over here is KC gateway. So I'm going to use these two things here. And then I specify my Docker repository name, and I'm logged into the Docker here. So I have my Docker account on this particular name. So I'm just going to use it so that it makes it easier for me to push the image to that particular file. So that's basically it. In order to generate a file, what I'm going to do is basically I have the app.kdl here. I just have to run JHipster, JDL, and app. And this should generate everything for me. So this will run the script, and this will generate all the things that is required. Let's go ahead and see how it's going to look like. The file is now generating. So as you can see here, I have most of the things that is getting generated. So I have 3 folders now. First is the Docker Compose, because we have specified a Docker Compose deployment type. So it puts in all the Docker Compose related files inside. And then I have 2 applications, KC blog and KC gateway. And if you take a look at the KC gateway, it's a normal Spring-based application. There is nothing fancy in here. It's pretty normal. One of the nicer thing I would say is we have this Docker files embedded inside it. So if you want to run it, you can just use this Docker file to just straight away run this entire application for you. And then you have this Java file where you have the entire application starting over here, and we can take a look at like the REST service. You can see there are different services here, account, and which uses all those things that we have here. So as you can see here, it uses mono, which is reactive way of calling it, and then it calls the register user over here. And then if you go to register user, this does everything, and everything over here is reactive, and that's the entire reactive application that you have. And it also like it uses all the best practices that we have, like putting all the configurations together, and the domain here, and then the management side of things, and finally the repositories and all those things. So it's all the good practices followed, application generated. And then similarly, you have the front-end based application over here. We use Webpack, so Webpack is also added over here. And it also uses microfrontends over here. So that is how your gateway looks like. When you go into blog, you can see the difference over here, where I added a lot of entities to the blog, so you could have all those entities created over here. So inside the web REST, you have the blog resource, which is nothing but a blog controller. It has all the things that is required. So here I'm creating a blog, and then I have an update blog with a nice documentation and all those things added to it. So I have the entire set of things available. So now my application is generating, so it is also running the deployment and everything. So my applications are completely installed, my application is completely generated, and everything is ready. And it wants me here, like it also generates a Docker Compose file. So if you go ahead and look at it, so there is a Docker Compose file that was generated. So it has all the application things here. And this boots up the gateway, this boots up the database attached to it, the blog, which is the next service, and the database attached to it, and the JHipster registry. Since we are talking about microservices, there is a mechanism in which you should have a registry which kind of registers. Spring uses that mechanism, and we have something called a JHipster registry, which kind of helps you to register all those services and enable the communication between those registers. It's a service discovery that we are using. Since we have used Eureka, we have the inbuilt Eureka with the help of JHipster registry, which is another open source application we have. So everything is wired up and we have everything ready. So now if I have to do it, I just have to build this Docker image and push this Docker image to my repository, which is the Docker Sendil command and repository, and then use that values database. So what I'm going to do now is I'm going to just go ahead and build both the applications. So I'm going to generate I'm going to generate the Docker images for this one, and also I will go ahead and do the same thing for the blog. So I have generated both the things here, and it will run a bit, and then it will stop. But now I'm missing one particular thing over here, which is generating the Kubernetes configuration file, which was not generated out of the box. So I have to generate it manually, because Kubernetes is not something everybody is going to use. So that's the main reason we are not generating it out of the box. And if you want to generate it, it's very simple. I'm going to create a directory called SKAS to put in all the Kubernetes configuration file. Go inside that file, and then go inside the directory, and then run JHipster K8s or Kubernetes. So it's going to ask me a couple of questions, and based on that answer that I provide, it will create all the configuration files required for me. So I'm going to say I'm going to generate this configuration for Kubernetes for the microservice application. So I'm going to select it. I'll ask where my gateway and all these services are located. It's actually one directory below, so I'm just going to use the default value. It automatically identified the two folders that we have, which is the JHipster application. And these are the two things that I wanted to create Kubernetes configuration for. So I'm going to select these two things. And it asks like whether I want to add something like Prometheus for extra monitoring. For this demo purpose, I'm not going to do it, but if you want, you can add it. So I'm just going to give no here. And it also says me, it also says me like, okay, I'm using JHipster registry, which is my service discovery. And it is like, what is the password that I want to use? I'm going to use the default one, which is admin here. If you're doing it for production application, for your own application, use a stronger password. And also say, what is the namespace where you want to deploy it? I'm not going to create a new namespace right now. I'm just going to deploy it on the default namespace that is available. And the Docker repository name, which is my Docker repository name, where the images it has to push it from and pull it to. And also what is a basic command that I'm going to use for Docker push. You can also use gcloud push if you're very big on gcloud. And whether you want to add an istio for here. Since we are using Eureka for service discovery, adding an istio is meaningless over here. Istio also talks as like service discovery for you. So I'm just going to say no. I'm going to use load balancer. This assigns an IP and exposes an IP for you, so you can use that stuff over here. And it's not going to be stateful service, so I'm just going to say no. So as you can see here, now I have all those things generated for me, the Kubernetes configuration. Let's go ahead and see the Kubernetes configuration first. It has this Kubernetes configuration, which is also following all the best practices. You have a README file which says like what you have to do if you want to deploy it. It has the registry, which is JHipster registry, where all those things run, all the service discovery works, and all the things that is required for this to do, all the environment variables that is required for it to run. And then we have this gateway application, which creates one for deployment. The deployment is where your application resides, and it determines how your application boots up, what are the environment value that you're going to spend it for your application. You have this PostgreSQL, which is your database-related stuff, Kubernetes configuration, and then you expose it as a service, and you expose it via load balancer, which means it assigns an IP to it. So with that, all the configuration generated, now all we have to do is we have to check whether the application, the build was success. So both the generation of the images were success. So we have the images ready. So what I can do is like I can just tag those images and push those things into my Docker repository. So now my Docker will have these images ready, and it will be pushed into there. So I have these two images inside the Docker hub. So let's see what's going to happen over here once it completes. And if you take a look at README, you can also straight away generate it using the same command, w boot into a jar as a production build using JHip and put that image into this particular location. You can also straight away use these two commands. Instead of building it once and pushing it in a normal old way, you can also use this thing. And finally, you can just run this command bash kubectl apply -f. So I have my Kubernetes up and running. So I have also connected my Kubernetes over here. So I can just do kubectl apply. And what it's going to do is like it's going to push all those things to the cloud. And if I switch back to my cloud over here, so I have my cluster here. And if I take a look at the workload here, so as you can see here, it starts with a red thing here because it's kind of like booting up now. And it will slowly turn into green. I hope so, if my demos went good. And also you can see over here, since we have decided this, how do you call it? Since we have decided that as load balancer, you could have something like an external IP over here. So this is my thing. It's creating an IP now. Once it is assigned, then you will have something similar IP over here, and that with which you can go ahead and access your application straight away. So we have the IP. I'm just going to open it. I don't think it will have opened it. And as you can see here, it will take a bit of time to run. And yeah. Meanwhile, I can showcase this application, which is a demo one that I've created before. Let's see the logs, what is happening over here. So I'm just going inside. You can check the logs over here. Yeah, Kubernetes, how it works is like it makes itself like unschedulable and does not have minimum availability. These are the common errors that happens on the GCP itself. But after a while, it gets deployed and it takes a little bit of time to get the deployment correctly working. And let's see how long it is going to take. But meanwhile, I can also showcase this. This is an exact same application that we have generated. So this is a gateway, and this is an application. I can log in here, admin. So as you can see over here, I have my ND application generated, and this is the UI which has this user management part of it. So I have a couple of users with admin and user, and then the gateway part of it, which shows like what are the applications that are ready. We have two applications, one on the blocker, and the one is JHipster registry, which is nothing but your service discovery. And then you have this tag, so I can create a new tag. I can create a new tab, something like test, and then I can save it. Let's go ahead and save it over here, so I can go ahead and edit and things like that, so I can do all those things that is required. And similarly, since we have added dependencies, I could also add in over here, not here. So let me check. The post has some tags, so I can create a new post. I can say like test. I can put some content here. I can select the block that I have already done. And there are tags that was defined. So test is one of the things. I'm just going to save it. So now all the dependencies that you have created, all the one-to-many mapping and many-to mapping that you have done, basically we also created a UI for that. So you can choose ahead and do that thing together over there. So that's basically it. And let me see whether it worked. No, it takes a long time. So let's do one thing. Let's try to delete these things. I just nuked my working stuff. Let's see what's going to happen. But that's basically how it's going to generate, how it's going to create everything. And yeah, as you can see, it starts something. So parts are starting to be ending. That's a good sign. Let's see whether it's going to generate. But going back here, since we have done it as a micro frontend architecture, one of the major thing that we have to take a look at it is like the web app part of it is also present on the KC block, which is a microservice. So each of the microservice will have its own web part of it. And this microservice contains all those things that are related to particular things. So here you have this entities, which has blog post and tag, and all the things related to that. Entities are added over here. So that's basically it. And yeah, I think that's basically it. Let me check one more time. Something has changed. Yeah, so now it will take a little bit more time to boot it up, but now you can see like the databases are up and ready. Now the application will start booting it, and then you can access the application using this stuff. I'm going to go back to the slides. And yeah, so what we did so far, we started with the microservices, and why do we have microservices? What are the what it brings into picture, and how reactive microservices helps us to make it much more even better, and also add in a lot of complexity. And then a little bit about Spring Reactive, what it is and what it brings to the table, and how JHipster makes it easier for us to develop an application. We generated a microservice. We went through code a little bit. We didn't deep dive much into it. And finally, we deployed the entire thing on the Kubernetes and checked how it works. So that's basically the entire thing. And with that, I'm going to stop over here and wait for questions.
All right, so we do have one question that came in from Justin. How does JHipster make money?
Wow, that's a good one. It's an open source project, right? So we are not focused on making money over here. So we are just creating this as an open source project. We do have sponsors who kind of help us out, and we use that sponsorship money that we're getting from the sponsors using Open Collective. We are giving it to the customers. Like we are giving it not to the customers, to the contributors who are contributing to our code base. So basically, we have bug bounty program and things like that where we kind of assign bounties to the bug, and people who are going to complete it, it's an open source project, so it's in GitHub. So people who are going to complete it will get money from that. So we are using that sponsorship money for our contributors and our people who are using that. Yeah, that's what we are doing, and we are an open source project. That's it.
Right. If there's any more questions, feel free to put them in the chat. We'll hang out for another minute or two. So I have a question for you, Sendil. Yeah. What is a real-world application of using a reactive service? Do you have an example that you could share?
Real-world application? Okay, let me think. I don't want to share the obvious one, so I have to go around the bush now. So yeah. I think most of the things that you see right now, if it relates to millions of, if it addresses millions of users for you, then it's kind of using reactive application behind it. And if you have more concurrent connections, if you are doing like, hey, your ticket booking website and things like that, that are going more reactive nowadays, just to ensure that it handles the capacity and the workload that is coming towards it, and maintain that. So that's how it's going to use. I'm particularly dodging the main bullet now because I'm not sure whether I can share or not. That's it.
Right. All right. Another question that came in through the comments on YouTube. How long has JHipster been around, and what does the future look like?
Yeah, I mean, like, JHipster is around for a very long time. I think like it's more than 7, 8 years. I think it's been a very long time. Initially, we were just focused on AngularJS, a little bit on the front end, but more focused on the back end. But now we have the full stack application generator. And now what we are going is like we're going in the direction of modules and blueprints, where like we don't want to force our users to just use what we are generating, but we want to enable them also to write the templates and everything and use that template instead of what we have. That's how I started writing Kotlin Hipster, which is nothing but just take the Java code that we're writing, remove that out, and then use Kotlin code instead of Java code. And that's basically it. So similarly, if you're having your customers or clients that you're helping them out building applications, I would say like think about blueprints where you can customize the front end as you want, you can customize certain parts of the application as you want, and use the generator that we're generating altogether, and which makes it much more simpler. I've done it in the past, like when I was doing consulting, I have done that particular thing where I kind of added mods for those particular modules and then created those applications much faster. And that turned out to be much more effective way because we have all the good things inside the application. And the future is more towards like bringing in more patterns and making the code much more smaller. We have something called JHipster Lite, which is basically like stripped down version of JHipster where we're going for hexagon architecture and trying to build smaller things better and increase the scope much more. Like you can add component by component and build that. And that's what we're doing. And we're also brainstorming what we need for JHipster 8. And if you have some cool suggestion, come to the GitHub repository and go ahead and give your suggestion, and we will definitely consider that.
All right. All right. It looks like we're not getting any more questions coming in. So Sendil, thank you on behalf of the Kansas City Java user group. And thanks everybody for tuning into the stream. We will see you next month.
Yeah. Thank you, folks. Thanks, Brandon. And also to Billy. Yeah. Thanks. Bye.
Thanks, everybody.